video, I want to show you how to find the derivative of inverse trigonometry functions. Most students always think that this is very difficult, but it's pretty basic. Once you follow the rule and instruction, you're just right there. And we have these three major ones that I want to use as an example: arcsinx, arcosx, and arctanx. Of course, there are other complex part of it where you have to use the function of function, which is the chain rule and all of those. But let's get right into it. Let's start with arcsinx. The first thing you do here is that you're going to take the sine of both sides here. Why? Because I want to get rid of this arcsine. That is where the whole thing starts from. So that's the first thing you do when you want to find derivative of arcsine of any function. So if you take the arcsine of both sides, this implies that sine of y would definitely be equal to sine of arcsine of x. Now, so from basic trigonometry, we know that this one will still remain sine y. Of course, this one will still remain sine y. And if you take the sine of the sine inverse of something, then you're just going to get that. So that means that if y was here, sine of arcsine y, that is going to be y. Sine of arcsine theta, that's going to be theta as well. So and so on like that. So this is just going to be equal to x. So it's almost like we're having a new function here, which is x equals sine y. So what do we do real quick? What we do is that now it's like x is a function of y. Let us find the derivative of x with respect to y. So it's very, very easy. If x is a function of y, then we can say that the x dy. Initially, if y was a function of x, we would have said dy dx. But now that x is a function of y, we're saying dx dy. So dx dy equals, so when you find the derivative of sine y, you're going to get cos y. And all you need to do here is to multiply through by dy. So if you multiply through by dy, you're going to get that dx is going to be equal to cos y dy. And this is where the whole thing starts from. Don't forget, what we actually want to get is the y dx. That is exactly what we want to differentiate y with respect to x, but what we have is dx dy. In fact, this is just you trying to be more professional. You can actually just take the inverse of this and then you'll be all right. But that's not the final thing we need to do. So if you manipulate this is going to give us that if cos y comes down here, so you have 1 divided by cos y, and if the x goes to the other side, you have dy dx on this side. But we want this function to be in terms of x, purely in terms of x. So how do we go about that? You will recall from basic trigonometry, one of the trig identity is that sine squared of x plus cos squared of x equals 1. So what does this imply? This implies that if we have cos x, that would be equal to square root of 1 minus sine squared x. And here we have cos y. What does that imply? That implies that if we have cos y will also be square root of 1 minus sine squared y. So what does that imply now? So from the original problem, which we are dealing with, dy dx is then going to be equal to 1 divided by cos y, which is 1 divided by square root of 1 minus sine squared y. But that's not the end. If you look up, you realize that this sine of y was set to be x initially. So if sine of y is x, all I just need to do is to replace sine y with x in this place, and you have x squared. And this is the derivative of y equals arcsine x. So you have 1 divided by square root of 1 minus x squared. Now let's do that with the other two trigonometry ratios, and let's see how they look like. So for when we have arcosx, so the same thing, pretty much you take the cos of both sides. If you take the cos of both sides, you are going to be having something of this nature. Cos y is going to be equal to x. So if cos y equals x, that then implies that the x dy is going to be negative sine y. So we know that when we differentiate cos y, we're going to be having negative sine y. So this is because I've already explained. I'm doing this a little bit faster because I've already explained what we are doing in this place. So just take the inverse of this, which implies that dy dx equals -1 divided by sine y. So you recall from the initial thing that we did that sine y will definitely be square root of 1 minus cos squared y. So if that is the case, then this dy dx would then be -1 divided by 1 minus cos squared y, and this implies finally that dy dx equals -1 divided by 1 minus. So what is cos y according to what we have earlier? That is x. So this is going to be x squared. So you can see the difference between derivative of arcsinx and derivative of arcosx is just the negative sign. And finally, let's move to arctanx. For arctanx, we'll do the same thing as well. From here, we can see that tan of y is now going to be equal to x. So if you find the derivative of this with respect of x with respect to y, that would be sec squared y. When you find the derivative of tangent of a function, you get sec squared of that variable. So we have this now. So let's proceed, which this implies that if you find the inverse, dy dx would then be equal 1 divided by sec squared y. Now let's see our trigonometry ratio again, our trigonometry identity. Which one are we using here now? If we recall very well, we recall that 1 plus tan squared y will be equal to sec squared y. So if that is the case, we can simply replace this here. So that implies that dy dx is going to be 1 divided by 1 plus tan squared y, and finally substituting what the original tan y is. Tan y from where we started from equals x, so that will be 1 divided by 1 plus x squared. If you like this video, and if this video has made you understand how to find the derivative of inverse trigonometry functions, don't forget to subscribe and like, comment as well. I'll see you in the next one.